So my name is Mathieu Cortyl. I am the Managing Director for Europe and Asia Pacific in Tonisity International. And I would like to discuss about first week of lives, a challenging time for the piglet. First, I would like to quickly introduce our company, Tonisity International. So Tonisity International has been founded 5 years ago in 2015. We are based in Dublin, in Ireland, and we are dedicated to the development of innovative nutritional products, which are not only beneficial for animal health, but which also guarantee a real return on investment for the producers. We believe we are a research-driven company because in the last 5 years, we have conducted 139 trials in 31 different countries. Out of those 139 trials, 41 were research trials and 98 were producer evaluation trials. All those trials which have been completed today have involved close to 170,000 pigs, and I am quite confident by the end of this year we will be reaching 200,000 pigs in trials. So today I will discuss about the challenges faced by piglets in their first weeks of life. As you probably know, at birth, piglets have an immature intestine, and also because of the genetic improvement, the litter size increase every year, and this results in reduced weight at birth and increased pre-weaning mortality. This is leading to reduced performances and more time to reach the final weight. All this has for final consequences to reduce the economic performance of the farms. So my proposal today is to review all these challenges in this webinar, and tomorrow we will have a second webinar discussing what you can do at the farm level. So this is nothing new to you. In every country, we see a trend for more piglets born alive per litter, thanks to the genetic improvement. And on average, for the last years, we have seen that sows can give birth to an extra 0.2 to 0.3 piglets per litter every year. What are the consequences of the increased litter size? So I have listed here a few points that I am going to discuss one by one. So I will start with longer farrowing, increased number of stillborn piglets. I will continue on the negative impact on development of fetuses. Then I will touch a bit about the increased number of what we call intrauterine growth retarded piglets. The next topic will be reduced birth weight. Then I will spend some time on increased pre-weaning mortality. And I will also discuss the reduced performances and more time to reach the target weight. And all this leads to less than optimum economic performance. So the first point is longer farrowing. So as you know, the increased number of piglets born to term increased the duration of the farrowing, and this also increased the risk of asphyxia, which means that there are more stillborn piglets or compromised live-born piglets who might struggle to recover from a problematic birth. So as you can see on the graph here, for one piglet extra, we estimate that about 40 minutes extra for farrowing. Also, some very recent research has shown that the duration of the farrowing will increase when the last meal was given more than 3 hours before the farrowing. So litter size and farrowing duration, as we just discussed, more piglet per litter, longer farrowing, but the farrowing can also be longer with sow of higher parity and in sows experiencing high level of stress around farrowing. So it's very important to, if possible, reduce the causes of stress around farrowing. A longer farrowing will result in stillborn piglets and weaker live-born piglets which will struggle. The second point I would like to discuss is the negative impact on development of fetuses. And because of limited space during gestation, we see a negative correlation between the number of pig fetuses and the development of the individual fetuses. So this means that the higher the number of fetuses, the smaller they are. This will have an impact on the birth weight of piglets, as we will discuss later. Also, it has been observed that the embryos which implant first can physically restrict the development of later attaching embryo. And this will lead to variation in the development of embryos and variation in the birth weight of the piglets. The next point was the intrauterine growth retarded piglets, and the so-called IUGR piglets are piglets with lower birth weight and a higher brain to liver rate ratio, which is due to what we call the brain sparing effect. So nutrients are in priority redirected towards the brain. So this is due to the adaptation of the fetus to insufficient nutrition during gestation, and it can have permanent effect on the structure, on the physiology, the metabolism of the body, also on the intestinal morphology and the enzyme secretion. So those IUGR affected piglets will have a reduced growth and also a reduced development of muscle, which will pose economic problems because of higher feed conversion, reduced percentage of meat, and increased percentage of body fat in the carcass. The next point is the reduced birth weight. So an increased litter size has a negative impact on the birth weight. So as we discussed before, the size of fetuses is reduced in large litters because of less space and the reduce of nutrient during gestation. And as you can see here, the research has shown that for each extra piglet born, the body weight at birth is reduced by about 40 grams. This is the result of a study that was conducted on a farm, and they were recording the litter size, they were recording the weight of the piglets at birth. So what they have seen is that the first information, we can look at the blue curve. So the blue curve is showing you the average weight of the piglet at birth. When the litter size is less than 10 piglets, we see that the average weight of piglets is around 1.6, 1.7 kilo per piglet. And then this average weight is decreasing. When we have very large litters, more than 17, 18, we see that the birth weight on average is around 1.2 kilos per piglet. But also there is an impact on the different classes of weight. So first, if you look at the orange bar is showing you the percentage of piglets with less than 1 kilo at birth. They their number increase as the litter size increase. Same for piglets less than 1.3 kilo. So average weight is reduced, and also the number of small piglets is increased. The other information that you can find is that the average birth weight is affected by sow parity. And in this study, there was a clear trend for a parity effect. So what we can see here is that the more piglets born per liter, the smaller the piglets. This is something we already discussed, but also the parity is important. So sows from parity 1 tend to have lighter piglets compared, for example, to sows of parity 3 or 5. And parity 2 and 7 are in between. I mentioned earlier that a reduced birth weight also leads to a less developed intestine. And you can see here some photomicrograph of the mucosa of the intestine of piglets, depending on their birth weight. So on the left, high birth weight piglets, and on the right, low birth weight piglets. At birth, there is a difference in the size of the mucosa, intestinal mucosa, but this difference is also observed later in life and till the finishing period. So piglets which are born small have less developed intestinal mucosa, which will have an impact on their feed efficiency, for example. A reduced birth weight is also associated with reduced performances. So this is a study that was done on more than 5,000 piglets in Brazil, and they were recording the weight at birth, and they were recording the weight at different age, at 7 days, at 21 days, and at 59 days. So what do we see here? For example, at 7 days, for each 200 grams extra at birth, you have a difference of, on average, 64 grams at 7 days. At 21 days, this difference is almost 200 grams, and at 59 days, it's close to 1 kilo. So a piglet which is born, for example, between 1 and 1.2 kilo will be almost 1 kilo lighter at 59 days compared to another piglet which was born with 200 grams more. The next consequence of an increased litter size is, of course, increased pre-weaning mortality. You can see here data published by Interpig in 2018, and they show that in different countries, there is a trend for higher pre-weaning mortality as the number of born alive per liter is increasing. What we also know is that the pre-weaning mortality is mostly happening in the first week of life. This graph shows you that it's actually about 80% of pre-weaning mortality, which is happening in the first week of life. About 40% in the first day of life, another 40% in the remaining 6 days of the week, and then 20% of mortality is happening in the rest of the farrowing period. So in the farrowing house, sorry, before weaning. So here you can see it's very important if you want to intervene, it's very important to do something to reduce pre-weaning mortality before the first week of life. There are many causes for mortality of piglets before weaning. Those are related to each other, but there is a general agreement that crushing is the principal cause of piglet pre-weaning death, with chilling and starvation as underlying causes. So for example, if we look at this publication, which is obtained from data from 30 farms in Denmark, we see that especially from day 0 to day 4, almost 50% of the cause of mortalities are crushing. The second main cause is nutrition, poor nutrition, almost 20%, and then almost 20% also for weak-born piglets. This means that 85% of the piglets were dead because they had a low vitality. You certainly know already that pre-weaning mortality will increase when the birth weight is reduced. Here we have a summary of different studies, and what we can see is that less than 1 kilo seems to be critical for the pre-weaning mortality. So smaller piglets tend to have a higher percentage of pre-weaning mortality. Why? First, because small piglets are more susceptible to hypothermia, and this is because of the ratio between surface area and the volume, which is increasing. And there is a quite clear correlation between the piglet birth weight and the body temperature after birth. As you can see here, 30 minutes after birth, for each 200 gram extra, the piglet temperature is increased by half a degree centigrade. Degrees Celsius, sorry. So small piglets have a higher pre-weaning mortality also because they are more susceptible to weakness and hypoglycemia, especially within the first 24 hours of life. They have also more difficulties to compete for a teat. They have less vitality. Because of that, they consume less colostrum. They also have a less developed intestine. They have a lower immune status, and they are more prone to crushing. So smaller piglets have a higher percentage of pre-weaning mortality. But what I would like to ask here is, what does it really represent in terms of total number of piglets lost before weaning? So I was searching for information in literature which is available, and I first found this study. In this study, they were looking at the impact of litter size on the birth weight. And as you can see, about 90% of the piglets at birth are weighing more than 1 kilo. So when the litter size increases, you have more smaller piglets, but on average, around 90% of piglets are heavier than 1 kilo. Remember, 1 kilo was like the critical weight for mortality. So what they also observe is that when the litter size increases, the pre-weaning mortality percentage increases, and this is true for small piglets, less than 1 kilo at birth. For the heavier pigs, there is no clear effect on the litter size on their mortality. When you take into account these two parameters, so the proportion of large or small piglets at birth and the pre-weaning mortality in percentage, you can see that the majority of the piglets dying are weighing more than 1 kilo at birth, simply because there are more piglets weighing more than 1 kilo at birth. Another publication gives us similar information, and here this is a sow farm in USA with about 10.4 piglets per liter. They have 15% of the piglets which are less than 1.09 kilo at birth, and almost 85 more than 1.09 kilo at birth. The pre-weaning mortality in percentage is higher for the small pigs than it is for the larger pigs, and as a consequence, there are more pigs, more of heavy pigs that were lost before the weaning. Same conclusion in a study in Brazil, where this time we had close to 60% of the piglets lost before weaning that were weighing more than 1 kilo at birth. Tonisity has done a lot of trials on this subject, and I'm going to share you a few results here. So the first one is a commercial farm in Brazil with close to 12 piglets per liter. We are weighing here the piglets at day 2, not at birth, and we see that we have 90% of the piglets which are weighing more than 1 kilo at day 2. And those piglets have a pre-weaning mortality of less than 10% compared to 31% for the smaller piglets. However, the number of piglet lost, there are 72% of piglet lost which were weighing more than 1 kilo at birth, and this is simply because there were much more of those piglets at birth. Another trial conducted by Tonisity, this time in Spain, in a farm with 13.3 piglets per liter. Again, we weigh the pigs at day 2, not at birth, and we have more than 90% of the pigs weighing more than 1 kilo. They have a mortality of around 11%, which means that close to 72% of the piglet lost before the weaning are actually heavier than 1 kilo at the beginning of the trial. The last information, or the last trial, also conducted by Tonisity, this time in the UK, and we see exactly the same trend. Almost 80% of the piglets that were lost before weaning were weighing more than 1 kilo at birth. So if I summarize all those trials in one graph, I can see that on average, 71% of the piglets dead were weighing more than 1 kilo. So many times when you discuss with farm managers about pre-weaning mortality, they will tell you that the issue is with small piglets. If you are looking in terms of percentage, they are totally right. The pre-weaning mortality in percentage is higher for small pigs. But if you are looking at number of pigs, which is the important criteria, we have to consider that the fact that we are losing a lot of heavy piglets or good quality piglets. So smaller piglets, less than 1 kilo, will represent on average about 10% of the total population and 20 to 40% of the total number of piglet lost before weaning. So this means that 60 to 80% of the piglets dead before the weaning are what we can call good piglets. For example, on a 1,000 sow farm, which has 2.4 liters per sow per year, 15 piglets born alive, a pre-weaning mortality of 13%, this farm is potentially losing 4,680 piglets per year. Out of those, 70% means almost 3,300 piglets were born with more than 1 kilo and were lost at weaning. So if we can save those piglets, there will be a big impact on the profitability of the farm. Because as we know, the pre-weaning mortality is impacting the cost of production. So the cost of production is increasing with pre-weaning mortality. Now I would like to talk a little bit about the importance of the colostrum. We know that the first step is to get sufficient colostrum to the piglet. And of course, the first 24 hours are crucial for the colostrum intake. The colostrum has a high caloric density and provides the piglet with immunoglobulins. This is very important because there is no passive transfer in utero. So colostrum is the most important source of immune material and energy for the newborn pig. In terms of energy, research has shown that the colostrum supplies the piglet with about 6 kilojoules per gram absorbed. Looking at the colostrum composition, you can see on the left, you can see the different type of colostrum: early colostrum, mid colostrum, and late colostrum. The main change over time in composition of colostrum is the concentration of protein, which is going down. And this is related to the concentration of immunoglobulins. So the concentration of immunoglobulins is reduced over time. You can see that it has dropped a lot after already 12 hours. And you have to remember here about the duration of the farrowing. Farrowing can last up to 9 hours, which means that the piglets that were born, the last ones, have a much less quantity of immunoglobulin in the colostrum they are going to drink. And this is proven by research. Here we have the immunoglobulin concentration in the serum of piglet, at 2 days of age and at weaning. You can see that the first two born piglet have a higher concentration of immunoglobulins compared to the last two born piglets. One of the challenges for the farm manager is that the total colostrum production is not increasing when the number of live-born piglet is increasing. So you can see here that if you have 10 piglets per liter, or if you have 18 piglets per liter, the average production of colostrum remains the same. There are, however, some factors which are limiting the colostrum production, and they are mostly related to the sow. For example, the parity. So sows from parity 1 to 3 will have usually a higher volume of colostrum compared to sows from parity 4 to 7. A study has shown that sows from parity 1 to 3 can produce almost 4 kilo of colostrum, whereas sows of parity 4 to 7 can produce less than 3 kilo of colostrum. The volume of colostrum produced is also related to the mammary development, the endocrine status, the metabolic status of the sow, and of course the nutrition of the sow. It's very important, the quality of the feed and the quality and quantity of water given to the sow. Stress has also a big impact. So stress caused by environment or also caused by management. So for example, induced farrowing can reduce the quality of the colostrum. Increased farrowing duration will decrease the yield of colostrum, the volume of colostrum. So if we have the same volume of colostrum produced by the sow, irrespective of the number of live-born piglet, this means that the quantity of colostrum available per piglet is reduced when the litter size is increasing. So here I take two examples. If you have about 13 piglets born alive, potentially each piglet could get 250 grams of colostrum. If the litter size is increased to 15 to 16, potentially each piglet can get access to 200 grams of colostrum. We also know that the colostrum intake is increasing with the birth weight of the piglets. So piglets which are smaller drink less colostrum, and this is related to their vitality and ability to move. Also, mortality of the piglets is increasing when the the colostrum intake is decreasing. So mortality of the piglet is increasing when the colostrum intake of the piglet is decreased. So here, for example, you can see that if piglets drink less than 100 grams of colostrum, they have a mortality close to 30%. When they increase their quantity of colostrum intake, their mortality decrease, and it seems that above 300 grams, there is no impact on the volume of colostrum on the mortality of piglets. So based on all the published research, we can wonder what's the quantity of colostrum we should give to piglets. So according to different publications, you need at least 150 grams of colostrum per piglet just to meet the energy requirements. You need 200 grams to reduce the pre-weaning mortality. You need 250 grams per piglet to ensure a good health status and the proper growth. And if you increase this quantity to up to almost 300 grams in this publication, piglets were 2 kilos heavier than the other ones at 6 weeks of age. Also, trying to be practical, I would like to give you here some indicators of low colostrum intake and increased risk of pre-weaning mortality. So the first indicator is the body weight, and the risk increases if less than 1.2 kilos. So if the piglet is less than 1.2 kilo, it means the colostrum intake will be probably less and the mortality will be higher. Same for body temperature. The risk factor is less than 37 degrees Celsius, skin temperature 30 degrees, latency to moving 15 seconds. So a piglet that does not move within 15 seconds is potentially a piglet that will not drink enough colostrum and will die, will have more chances of dying. Standing 5 minutes, teeth 25 minutes, and suckle 30 minutes. So a piglet that does not consume colostrum within 30 minutes will have a lower colostrum intake and will have higher chances of dying. Some tips for the colostrum management. So first, we have to remember that the maternal sow colostrum is required for efficient immunity. To ensure that all piglets get sufficient amount of colostrum, one strategy that can be used is called the split suckling. So this is very important in large litter to ensure the proper colostrum intake. So separate the litter in two and alternate the two groups of piglets to give them access to colostrum for the first few hours of life. Also, it's advised to not to do the cross-fostering before 6 hours after the colostrum ingestion. However, it's recommended to do the cross-fostering before the establishment of the teat order by littermate. That's why the cross-fostering is usually practiced within the first day of life. Ideally, the small piglets should remain on the maternal sow, but in practice this is not easy, and in practice usually small piglets are transferred to a second or third parity sow. Why? Because teats are more accessible and they are easier to suckle on those sows. Another challenge for the piglet is the weaning. So weaning, as we know, is a stressful event for the piglets. So it's one of the most traumatic events in the life of the piglet. And stress is a major factor explaining the start of gastrointestinal tract disorders in animals and also in humans, by the way. The precise mechanism by which the stress induce or increase gastrointestinal disease susceptibility is not totally understood. However, results from different studies demonstrate that stress in pigs can result in significant alteration in multiple aspects of gastrointestinal function, including damage of epithelial barrier, nutrient transport function, and also immune suppression. In the early life and up to 12 weeks of age, the gastrointestinal system of the piglet undergoes significant development and adaptive changes. So first, the colostrum and then the sour milk give the piglet protective passive immunity as well as important growth and immune factors. After the birth, we observe the maturation of the epithelial barrier. If you remember at the beginning, I mentioned that the intestine of piglets is not mature at birth, so we see the maturation of the epithelial barrier and the transport function, and also immune and enteric nervous system, which are here indicated by the green line. Those maturation and those processes are almost complete by 12 to 14 weeks of age. And those developmental processes, which are happening at this time before 12 to 14 weeks of age, exhibit a high degree of plasticity, and they will shape the adult phenotype and function of the gastrointestinal barrier. However, in our modern production system, we have a weaning which is happening much earlier than in nature. So it's not 12 to 14 weeks, but it's about 3 to 4 weeks. Here, stress factors such as weaning, mixing with other pigs, and infections of the gastrointestinal tract will compromise the gastrointestinal tract barrier development and function. Because early weaning is a significant stress for the piglet, this will cause intestinal injury, resulting, for example, in increased intestinal permeability and inflammation. And this will alter the normal gut development and lead to reduced performance and decreased resistance to disease. And recent research shows, for example, that the stress results in significant alteration in intestinal barrier, nutrient transport function, and neuroimmune mediator and receptor expressions. So besides the impact of weaning stress on the gastrointestinal system, weaning also results in a period of low feed intake. And together, these consequences of stress have a negative impact at the intestinal level. So what we observe usually after weaning is a reduction in the size of the villi. We see a decreased number of enterocytes, enterocyte being the intestinal cells that absorb the nutrients. We also see lower maturity of those enterocytes and reduced absorptive functions. There are a lot of publications demonstrating the impact of weaning on the intestinal villi. And for example, this is one trial that was conducted by Tonisity with the University of Lerida in Spain. You can see that after weaning, we have a drop in the average size of the villi by about 40%. Here we see the relationship between the feed intake, the height of the villi, and the consistency of the feces in the first week after weaning. So you have two graphs. The first graph on the left is showing the relationship between the feed intake for the first week of life, days 3 to 7, and the height of the villi. So it's very clear that when piglets eat more feed, the villi tends to be taller. Also, it is shown on the right that when the size of the villi is lower, there is a higher incidence of inconsistent feces or diarrhea. And in this publication, they try to find the relationship between the input, which is the feed intake, and the output, which is the growth and diarrhea, and the small intestinal characteristic of the weaned piglets. So how to read this graph, which may be a bit complicated. I have put colors to make it easier to understand. So green arrows mean a positive association. Red arrows mean a negative association, and dotted lines show no clear association. So feed intake is positively impacting the height of the villi. The height of the villi increasing is positively impacting the activity of the enzymatic activity, and feed intake also has a positive impact on enzyme activity. Also, the diet composition can have an impact on the feed intake. Of course, a more palatable feed is more easily consumed. There is no clear effect between the diet composition and the height of the villi. Better feed intake, taller villi, and more enzyme activity all lead to better growth performance of the piglets. The diarrhea, as we know, has a negative impact on the growth of the piglet, and it seems, as I have shown earlier, that diarrhea is negatively correlated with the height of the villi. So here are my take-home messages. The first is that the current trend for increased litter size result in increased pre-weaning mortality and reduce economic performance. Also, in terms of percentage, the incidence of pre-weaning mortality is the highest among the small piglets. However, if we look at the total number of piglets lost, the picture is different. Pre-weaning mortality in terms of number affect a lot of piglets that were born more than 1 kilo, that they were weighing more than 1 kilo at birth, sorry. A good colostrum intake will provide immunity, will reduce pre-weaning mortality, and will also ensure a proper growth. Weaning is another difficult phase and a major source of stress for the piglet. So low birth weight and weaning result in shorter villi, impaired function of the intestine, and negative consequences on the immune system. So tomorrow we will have a second webinar, which is early intervention for improved lifetime performance of pigs, during which we will discuss the science behind solution designed by Tonisity to help the piglets in these challenging periods. So the second webinar is tomorrow, 30th of April, at 10 a.m. in Europe's CEST time, and 3 p.m. as well, so 2 sessions, one in the morning, one in the afternoon. So thank you for listening. If you have questions, I'm happy to answer.
Hey Matthew, Connor here. Just one quick question for you. You said that the process of gut development in early life of the piglet has a high degree of plasticity. Can you explain that in a bit more detail?
Thank you, Connor. Yeah, I knew that might be a bit confusing, so I'm just going to this slide, and it is here, plasticity. So what it means is that the development, the changes happening in the body during the growth of the pig, all the changes happening in the body of the pig are a result of genetic programming, but also some of those changes are influenced by signal from the environment. And this is why we talk about plasticity. It means that it is possible to positively or negatively influence the development of the gastrointestinal tract of the piglet, especially in the first weeks of life. So stress has a negative impact on the development of the intestine, as we just discussed. Tomorrow, in the second webinar, I would like to show you that it's also possible to have a positive impact on the gut development, which will have long-term consequences on the performance of the pigs and up to the finishing phase.
Thank you for that.
Welcome.
There's another question here just asking, is it possible to get a copy of the recording of this presentation?
So yes, so if you have registered for this webinar, you will get later in the week a link to be able to listen again to those webinars, no problem. Do we have any other questions? Not yet, no?
I'm sorry, but I'm not aware what is parity.
Parity, this is Mario speaking, right?
Right, that's
Okay,
Mario.
Mario, hello Mario. Parity means the number of cycles the sow had. So the gilt, when they go for the first time in the farrowing house, this is the first parity. And then they come back for the second and third, and usually up to 7 parities. So it means the number of liters they had.
Okay, thank you.
You're welcome. So if there are no other questions, I propose that we stop here. I will stop the recording. Thank you everybody for your time and for listening. Thank you.